Now, today we are going to talk about integration of hyperbolic functions, formulas, and let's have some examples. Let us be familiar with these formulas for integration of hyperbolic functions. So let's start with the first one. We have integration of hyperbolic sine u du. This is equal to hyperbolic cosine u plus c. And if we have integration of hyperbolic cosine of u du, this is equal to hyperbolic sine of plus c. If we have integration of hyperbolic tangent of u du, this is equal to ln of the absolute value of hyperbolic cosine of u plus c. Then if we have integration of hyperbolic cotangent u du, this is equal to ln of the absolute value of hyperbolic sine of u plus c. If we will have the integration of hyperbolic secant squared u du, this is equal to hyperbolic tangent of u plus c. If we have integration of hyperbolic cosecant of squared du, this is equal to negative hyperbolic cotangent u plus c. So if we will have integration of hyperbolic secant u times hyperbolic tangent of u du, this is equal to negative hyperbolic secant u plus c. And if we have integration of hyperbolic cosecant of u times hyperbolic cotangent of u du, this is equal to negative hyperbolic cosecant u plus c. So these are the formulas that you need to be familiar with in answering or evaluating hyperbolic functions. So now let's proceed to some examples. So the first example, we have integration of hyperbolic sine x times hyperbolic cosine squared x dx. Now, with this example, we need to be familiar with the substitution for integration in some formulas that we have. But with this one, we don't have basic formulas for integration of hyperbolic function. But if we will try to let cos or hyperbolic cosine of x, right, as my u, right? Therefore, I will get du as equal to sine hyperbolic sine of x dx. So with that, I have sine x dx. I could substitute it. So this is equal now to integration of cos squared x, which this is equal to my u, which my cos x is equal to my u. So I will have u squared, right, for this one. And sine hx or hyperbolic sine x dx is equal to my du. So I'll get du here, right? With this equation now, we can make use of our power rule for integration. So this is equal to u 2 plus 1, that's 3, right? That's the exponent all over 3 plus c. This is not yet the final answer because our values are in terms of hyperbolic function. So this is equal now to u is equal to hyperbolic cosine x. So we will have hyperbolic cosine cube x, right? All over 3 plus c. This is now our final answer. Let's have our second example. We have integration of hyperbolic secant squared t dt. With this example, if you try to check your formula, this is a part of your formula, which this is equal to hyperbolic tangent of t plus c, right? This is now our final answer for this example. So the goal is to be familiar with your formulas for hyperbolic functions. How about this one as our next example? We have integration of hyperbolic sine square root of x all over square root of x dx. With this example, we are involving with the radicand symbol, and if I will try to let my u is equal to square root of x, my du is equal to 1/2 times x raised to negative 1/2 dx, which this is equal to 1, or I will write it this way, dx all over 2 square root of x. So I need to isolate this term here, dx all over square root of x, so I could substitute my value. So this is equal to 2 du is equal to dx all over square root of x. So with that, I could substitute my values now. So this is equal now to integration of hyperbolic sine of square root of x, that's equal to my u. Then dx all over square root of x is equal to my 2 du. So I could factor out my 2 from my integration element. So I will have 2 integration of sine hyperbolic sine of u du. Now, this is part of our formulas. Part of our formula. So this is now equal to 2 sine hyperbolic sine of u du. The integration of hyperbolic sine u du is equal to cos u plus c. So I will have cos u plus c, but this is not yet our final answer because our terms are in terms of x. So now we will have 2 cos, my u is equal to square root of x, so I will have square root of x plus c. Now this is our final answer. Now let's have here another example. I have integration of x squared times the hyperbolic cosecant squared x cubed dx. So this is your angle here next to your hyperbolic cosecant squared of x cubed, which this is our angle. So if I will let u is equal to x raised to 3, my du is equal to 3x squared dx, which I have x squared, then I have dx. So if I will try to isolate my x squared dx, all over 3 for both sides, so I will have du all over 3 is equal to my x squared dx. So I could substitute now these values from my equation here. So I have integration of hyperbolic cosecant squared x cubed, which my x cubed is equal to u. So I will get hyperbolic cosecant of cosecant squared of x cubed, which my u, then my x squared dx is equal to du all over 3. So I could substitute du all over 3 here. I will factor out 1 all over 3, or 1/3, from my integration element. So this is equal now to 1/3 integration of hyperbolic cosecant squared u, right, du. So if you try to check, this is a part of your integration of hyperbolic function formulas, which this is equal to 1/3, right, times negative hyperbolic cotangent of u plus c. So this is not yet the final answer because our values are in terms of x. So we need to go back from the original variable. So I will factor out the negative symbol. So this is equal to negative 1/3. Right, I will try to write it nicely. 1/3 times hyperbolic cotangent of u, which is x cubed. So I will have x cubed plus c. So this is now our final answer.